Welcome back to BasicQuest.com. So this is the fifth post of the series. This series, as you know, is about building a pothole detection application. So in the first series, first post of the series, we started off with introduction to object detections, and in the second post, we annotated the images using label IMG. And from the third post onwards, we started with different algorithms. So we started off with sliding windows and image pyramids in the third post. Fourth post, we discussed about RCNN. And in this post, we are getting into YOLO, and we are particularly dealing with YOLO 5. So if you haven't seen the earlier videos, I would recommend you to visit the earlier videos and the blog post. So every videos are embedded in the blog post, so you have a good learning experience. So let's dive into YOLO 5. YOLO is one of the most popular object detection algorithms which is used today. So YOLO stands for you only look once. So unlike the RCNNs which we saw earlier, or the earlier versions of RCNN which we saw earlier, there were different moving parts. You had the classification part, you had the object detection part, which was using a searching algorithms parts. Unlike that, YOLO only have just one single network, and in one single network everything is achieved. That is right from object detection into predicting the bounding boxes, it is achieved in just one single pass of one forward pass of the network, and that's why it's called you only look once. So let's look at the overall process of YOLO. So you start with an input image just like this. So let's say this is our input image, which has say m batches, or m is the number of batches of input images with a certain dimensions. So this is first inserted into the network, and then you get an output. Let's look closely at the outputs. Now the output has got S into S grids. So this is there is something called a grid, which is the kind of output. Now all these different individual boxes is a single grid. So let's say you have say 19 into 19 number of grids, and for each grid you have a certain set of anchor boxes, what you call the anchor boxes, like this. Now when we looked into RCNN, we saw anchor boxes. You have anchor boxes of different sizes and different shapes. Like say for example, you have an anchor box like this, you have a tall anchor box like this, you have a wider anchor box like this. So it's the same concept. The purpose of these anchor boxes are to detect objects at different scales and at different locations. So let's say these are the different anchor boxes. You have in this picture we have got 5 different anchor boxes, and you could have different types of or different numbers of anchor boxes. And within each anchor box, there are basically 5 different predictions which we have. The first one is your what you call the score, the probability score. That is, this score indicates whether there is an object there or not. So depending on the probability score, you get to know whether there is an object or not. So if there is an object, the next 4 indicates the bounding box information. You have the X and Y coordinates and the width and the height information. And the last few are in terms of the classes of these of the object which is there. So let's say there are 10 different classes which we are going to which we have, or which we are trying to predict. So it will have 10 different 10 probabilities for each of those classes, and obviously the higher one is the actual class which is indicated in the for that particular box. And similarly for each of those boxes, each of these different boxes, you have these set of these 5 plus the number of classes you have, that many outputs. So these are the overall outputs, or these are the overall outputs which gets generated from a single pass of YOLO. Now we'll look into these different processes, and we look into each of these processes in detail in the next video.